So today we're going to prove this. In a parallelogram ABCD, the diagonal AC bisects the parallelogram into two congruent triangles ABC and triangle CDA. So first, let's write some things down that we know about this parallelogram. So we know that in a parallelogram, the opposite sides are congruent. So AD is congruent to BC. And we know that AB is congruent to DC. So now we have two sides of these triangles that we want that are congruent. So we have these two are congruent and these are congruent. So now we just need a third side if we want to use side, side, side to show triangle congruency. And so this would be the third side. And since it's the same line, it's also going to be congruent. So AC is congruent is equal to AC. And so using side, 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 we'll be able to figure out that these two triangles are congruent. So let's write that down. So first, let's write down what's given. We know that one, we have parallelogram ABCD with diagonal AC, and this is given. Nice. So next, we know that AD is congruent to CB. So we know that AD is congruent to CB, but this is by the definition of a parallelogram. And then we also know that AB is congruent to CD. And this is also by the definition of a parallelogram. And then we know that AC is congruent to AC by reflexive property. So by the reflexive property. So then we can say that by side, 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 since we have the three sides are congruent, we can say that triangle ABC is congruent to triangle CDA. By side, 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 and I'm just going to put the sides here, so we know that AD is congruent to CB, AB is congruent to CD, and AC is congruent to AC. So therefore, triangle ABC is congruent to triangle CDA. And there we go. The diagonal AC bisects the parallelogram into two congruent triangles by side, side, side.